Hello, welcome. My name is Ross Smith, and I'm a program manager within the Intune Customer Experience Engineering team. And you may be wondering, what's someone with Intune Engineering having a discussion with you about Outlook data and how to protect it with authentication authorization controls? Well, prior to moving to Intune, my focus was on Exchange. So I have a wealth of knowledge that span all the necessary technologies, how to use Exchange and how to protect your Outlook data with authentication, authorization, and even data protection mechanisms. My hope is by the end of this session, you'll understand what the different types of authentication mechanisms there are to authenticate against Exchange Online and how to protect them. And then finally, we're going to dive deeply into Azure Active Directory to understand what mechanisms Azure Active Directory provides, namely security defaults and conditional access. Depending where you are on your move to the Microsoft Cloud, you may be leveraging different authentication mechanisms to authenticate your users to allow them to access Exchange resources and their mailbox data. You could be leveraging legacy authentication, especially if you're in have on-premises mailboxes. Legacy authentication includes basic authentication, NTLM, and Kerberos authentication. Legacy authentication can even be used against Exchange Online through basic authentication. We know historically, legacy authentication leads to common identity-based attack scenarios like password spray attacks and credential stuffing that ultimately lead to data compromise. And so we need to think about, as we move to Exchange Online, how to disable legacy authentication. If we disable legacy authentication, naturally there needs to be a replacement for it. And that's where modern authentication comes into play. Modern authentication is nothing more than a fancy marketing term to describe OAuth, a mechanism by which we authenticate, and that authentication could be a number of methods. It could be your standard credential-based approach with the username password. It could be certificates. It could be passwordless through an authenticator-style app. But once the user authenticates, the user is authorized to access the resources they need through an access token solution, through OAuth. That access token has a period of validity, and after that token expires, a refresh token can be used to grant and obtain a new access token. Finally, that refresh token can be revoked. It can be revoked naturally through its lifetime, or it could be revoked by administrative action, such as disabling the account, or through a direct method to revoke the token itself. And of course, methods like changing the password would also revoke a token. When the tokens are revoked, that's when the user is prompted to authenticate a second time. Not only do we need to disable legacy authentication, but we must ensure modern authentication is also secure. One way to ensure that modern authentication is secure is by implementing multi-factor authentication. Multi-factor authentication is nothing more than something you know, like a password, something you have, like a device, and something you are, like biometrics. By implementing multi-factor authentication, we can reduce the likelihood of user accounts being compromised through identity-based attacks. Multi-factor authentication can be implemented through a variety of different mechanisms. I've mentioned one, an authenticator app. You could also do text messaging or a verification through a phone call. How do we go about disabling legacy authentication in Exchange Online? Through the Admin Center, we can disable on a per protocol basis legacy authentication. This gives you the granularity you may need to disable and allow certain protocols while you transition off of legacy authentication to modern authentication. And of course, you could use Exchange Online PowerShell through the new authentication policy commandlet. Now, in order to disable legacy authentication, you have to know what your users are doing, what protocols they're accessing, what services are being used, and the authentication model. Through Azure Active Directory sign-in reports, you can determine which protocols, which clients, and services are utilizing a legacy authentication mechanism to connect to Exchange Online. For example, you may discover that you have POP or IMAP clients that are still using legacy authentication. And so you'll need to transition them to a new client that supports modern authentication in order to disable legacy authentication. Or maybe you have a calendar resource booking solution within your environment that provides displays and everything else within your conference rooms to indicate when meetings are scheduled. Those solutions, which probably rely on Exchange Web Services or REST, may be using a basic or legacy authentication model for connectivity. So identifying what these solutions are is paramount to being able to disable legacy authentication. Now let's dive deeply into Azure Active Directory to understand what controls we have available there. There are effectively two paths within Azure Active Directory available to you, and it is ultimately dependent upon your licensing and the need for customization. If as an organization you don't have licensing that includes Azure Active Directory Premium P1 or P2, then you'll want to leverage security defaults to manage and protect your users' authentication. If, on the other hand, you have the licensing or you need to be able to create custom policies for managing the authentication requests, you should leverage Azure Active Directory Conditional Access. Security defaults is Microsoft 365's solution to help mitigate against common identity-based attacks like password spray. Security defaults does two things out of the box. It first disables legacy authentication for all Microsoft 365 endpoints and requires users to register for multi-factor authentication with the Authenticator app. Multi-factor authentication is required under specific scenarios. For example, if the user attempting to authenticate is a member of a privileged security group or has a role like being an Exchange administrator, then MFA will be required in order for them to successfully authenticate. Likewise, if a user attempts to access a privileged process like the Azure portal, multi-factor authentication will be required. For normal users, Azure Active Directory will require multi-factor authentication on a case-by-case basis, depending on whether Azure Active Directory believes that the account is suspicious in nature. Unlike the Exchange Online management controls that enabled you to customize what legacy authentication protocols you would allow or block, security defaults provides no granularity in that case. It is on or off, and for all new tenants, it's on by default. If you need granularity in managing certain settings related to protecting against common identity attacks, you should consider conditional access. Conditional access is nothing more than a policy-driven approach within Azure Active Directory that takes a set of assignments and then makes an intelligent decision on whether to block access or allow access. From an assignment perspective, we look at the identity, who's attempting to authenticate, and we look at the cloud apps they're attempting to access. And then finally, we look at several conditions, like what location they're authenticating from, what device platform are they utilizing, what client apps are they using, and we can even, depending on your capability in terms of licensing, look at risk. We can look at the user risk. Is this account compromised, and thus should we force a password reset? Or is this authentication request or prior authentication requests suspicious in some nature? And if so, we can then make a decision of whether to block access or allow access based on the combination of assignments and conditions. Now we have a number of conditional access best practices, and you can find all of them detailed in the link at the top of this slide. However, I want to focus on a few key important best practices. First and foremost, you want to use the Office 365 Cloud app in your conditional access policy targeting. You don't want to target individual specific cloud apps where possible. The reason for that is twofold. There are some services, like Teams, for example, where they have interdependencies amongst other parts of the Microsoft 365 service infrastructure. For example, Teams relies on Exchange Online and SharePoint Online for data storage. So having a conditional access policy that targets Teams, but say blocks access to Exchange Online or SharePoint Online, will lead to an unsuccessful authentication request, as the user will not be able to authenticate and access the Teams service without being able to access either Exchange Online or SharePoint Online. And this ties in with my next best practice, which is do not create a block all except X type of policy. Conditional access should not be thought of like the traditional on-premises firewall model. This is not a model in which you block everything and only allow certain services to come into play. You actually want to create and focus on a model where you're allowing service access, and by definition, blocking whatever is not allowed. Another example of how these type of policies can break is with the client apps themselves. If we look at the example of Outlook for iOS and Android, Outlook provides the ability to create tasks with the to-do service, join and create Teams meetings, integrate with the OneDrive for Business file picker, and supports access to the Office feed, among many other settings. It's this cohesiveness that we're building into our apps across the suite of the Microsoft 365 that provide the unique value proposition and usefulness of the architecture to your user population. By creating policies that block them from being able to access certain services, ends up resulting in a fragmented user experience within those apps, provided they can even access those apps, if we go back to that example of Teams. The other thing to keep in mind that unlike traditional on-premises firewall rules, conditional access policies don't have policy precedence. It is the combination of all policies that meet the conditions for that particular assignment that determine whether the user can authenticate or not. From a condition standpoint, I want to focus in this discussion on two particular conditions: device platform and client apps. Their names kind of give away what they mean. From a device platform, it allows us to target and scope our policies based on whether the device is Windows, Mac OS, iOS, or Android. And from a client app perspective, we can break it down into whether the app is a modern authentication capable client or browser, or whether it's a legacy authentication client like ActiveSync or any of the other type of protocols that a user could use like POP or IMAP. And then finally, we have our conditional access grant access controls. These are utilized when you create a conditional access policy that allows access and further scope what must occur in order for a token to be granted to the user. First and foremost, we have the ability to force multi-factor authentication. This requires Azure multi-factor authentication and one authentication method. If the user has not set up multi-factor authentication, they will be prompted to do so. If the user doesn't complete their multi-factor authentication setup, then they will be prevented from authenticating. The next grant access control that we have available to us is require device to be marked as compliant. This grant access control requires the device to be enrolled in a unified endpoint management solution like Intune, and that the device must meet all applicable compliance policies for that particular device platform. This could include a mobile threat defense vendor solution or use of Microsoft Defender ATP to assign a device risk to determine the health of that device. If the device is either not enrolled or not compliant, then the user cannot obtain an access token. And finally, we have the require approved client app and require app protection policy grant access controls, which are scoped for mobile device scenarios specifically. The require approved client app grant access control has been available for a number of years and is a statically defined list of apps, mainly Microsoft apps, that have integrated the Intune SDK. This grant access control does not enforce that the user be licensed for Intune, nor does it actually require the Intune SDK to be in use. It only requires that the app in question that's attempting to authenticate have incorporated the Intune SDK. Require app protection policy, on the other hand, is ultimately the replacement for require approved client app. The require app protection policy grant access control requires app investment, though. It requires integration of authentication library, integration of the Intune SDK, and specific app changes to support this new grant access control. But instead of relying on a statically defined list in Azure Active Directory, use of this grant access control is ultimately defined by the apps defined in your app protection policies themselves. And this grant access control does what I refer to as policy assurance. Policy assurance means that an app protection policy must be successfully delivered to the app before an OAuth token can be generated and provided to the user. We also have, through conditional access, session access controls. And while there are several session access controls, the one I want to focus on is app enforced restrictions. App enforced restrictions can be applied to any device that is not considered managed. By managed, I mean any device that is enrolled. So with an app enforced restriction, we can target Exchange Online and ensure that when an unmanaged device attempts to use Outlook on the web, that we prevent that user from being able to download attachments or even print attachments, thereby reducing what data is left on that unmanaged device after the session ends. This is a great way to enable your users to be able to access their email on personal devices. So now that we understand what is included within conditional access, I thought it would be good to highlight several conditional access policies you could deploy in your environment. Now, in order to deploy these policies, there are several prerequisites. First and foremost, you must do all the work necessary to set up self-service password reset and MFA registration. You'll need to be able to disable legacy authentication, and you should be enrolling all your corporate devices with a unified endpoint manager like Intune to be able to access email content through the Outlook desktop or Outlook on the web. And finally, you're going to enable support for accessing Outlook on the web from personal devices and utilizing apps with app protection policies to access corporate data. The first policy that we're going to deploy is require multi-factor authentication. In this policy, we're going to set a number of assignments. We're going to target our user population, and we're going to target our cloud apps that we need to enforce multi-factor authentication against. While in this specific example, I'm focused on the Office 365 cloud app, we should be cognizant of the fact that you may have other services available within your tenant that you need to protect that aren't included within Office 365, like partner-based solutions. You should expand the scope of this policy to include all the services in which your users access, where you want to ensure multi-factor authentication is utilized. From a condition standpoint, we're not going to define any specific conditions for this policy. We want to simply target our users against the cloud resources and require multi-factor authentication. In the event that Jane attempts to access Outlook data, say Outlook on the web, Jane will be prompted to enter her multi-factor authentication mechanism. In this particular example, Jane is configured with password list-based authentication, so she's prompted to choose the corresponding number in the Authenticator app to confirm who she is. If, on the other hand, Jane does not complete the multi-factor authentication request, the access request will be denied, or the access request will be timed out. A denial occurs when Jane explicitly blocks the multi-factor authentication request because, say, for example, she recognizes that she didn't initiate the authentication request, so she can actually block the request through the Authenticator app and then inform IT security that there was a potential attempt to compromise her account. The next policy we want to deploy is for desktop, and this is where we require the Office desktop apps like Outlook to be able to access Outlook data. Our assignments are going to be the same as the prior one. We're going to target our identity and scope it to our users like Jane and target Office 365 as our cloud app. We're going to leverage two conditions within this policy. From a device platform perspective, we're going to target any device but exclude mobile. And the reason there is we want to ensure that we capture all Windows and Mac OS devices in this policy, in addition to any device where we don't understand or know what the device platform actually is. And then finally, we're going to target our client apps. In this case, we're going to specify any modern authentication capable client app or desktop app. This allow policy will use the required device to be marked as compliant grant access control, which will enforce that Jane's device must be enrolled and meet all compliance policies. If Jane is using an enrolled and compliant device, she'll be able to launch Outlook, obtain a token, and access her email. If, on the other hand, Jane isn't using an enrolled or compliant device, she will be blocked from obtaining an access token and thereby blocked from being able to synchronize her mail content. We want to do something similar on mobile and by requiring our Office mobile apps. So we'll target our assignments. Again, we're targeting our users against the Office 365 Cloud app. From a condition standpoint, we're going to target our device platform and specify iOS and Android. Now, we can get away with only specifying iOS and Android in this policy because our preceding policy would capture any device whose device platform was unknown and force device enrollment. Whereas in this policy, we can be granular and just be focused on specific iOS and Android devices that are being reported. From a client app, we're going to again target modern authentication capable apps. This allow policy will leverage two of our grant access controls. Require approved client app with an or operator between require app protection policy. And that's because we're in a transitory state where we're migrating apps from the use of require approved client app to the require app protection policy grant access control. Behind the scenes, Azure Active Directory has awareness of which apps already support the require app protection policy grant access control, similar to how it knows which apps support the require approved client app grant control. Azure Active Directory will ensure that the right grant access control is applied to the right app. So in the case of Outlook for iOS and Android, it will enforce the use of the require app protection policy grant access control, meaning that in order for Jane to be able to access her email in Outlook Mobile, an app protection policy must be successfully delivered before she can obtain an access token against Exchange Online. If, on the other hand, Jane attempts to use a modern authentication capable ActiveSync client like iOS Mail, Jane will actually be blocked by Azure Active Directory because iOS Mail is not defined on the require approved client app grant control list, nor does iOS Mail have the Intune SDK integrated within it. Azure Active Directory will notify Jane in its response that she needs to use an approved app. We need to think about how we're going to allow users to use their personal desktop devices to access Outlook on the web. So we'll create this policy where, again, we're targeting our users like Jane against the Office 365 Cloud app. And from a condition standpoint, we're going to target our device platform, again, targeting all devices with the exception of iOS and Android, thereby ensuring that this policy applies to Windows, Mac OS, and any device that is not reporting its underlying operating system platform. And then from a client app perspective, we're going to target our browser. And then we'll leverage the session access control, use app enforce restrictions. This will ensure that on personal devices, Jane will not have the capability to download or print attachments while in Outlook on the web. Our next policy will be around requiring a mobile browser, because as you can imagine, on mobile, you still have the capability to access Outlook on the web, SharePoint Online, or even Office.com. And we want to ensure any access to your tenant is protected by an app protection policy. So we'll craft our policy with the same assignments, targeting Jane with the Office 365 Cloud app. And from a condition standpoint, we'll be focused on iOS and Android device platforms with the client app configured as a browser. And our grant access controls will remain the same for mobile. We're leveraging require approved client app with an or and the require app protection policy grant access control. If Jane attempts to authenticate with the Edge for iOS and Android browser, the require app protection policy grant access control will be enforced, ensuring that an app protection policy is successfully delivered before Jane is granted an access token to access Office.com. If, on the other hand, Jane attempts to use a third-party browser like Safari, Chrome, or any other popular browser, Jane will actually be blocked from authenticating against any of your tenant resources, and she'll be told that she needs to use an approved app to access them. But we're not finished there. While these preceding policies all address desktop and mobile device-based scenarios for modern authentication-capable clients, we haven't addressed how we block legacy authentication. And so the next two policies will focus on that. The first is being block basic auth Exchange ActiveSync. In this case, we're going to target our users. And from a cloud app perspective, we have two options. We could target Office 365 Exchange Online or target Office 365. The reason why we can be granular with this policy is because Exchange Online is the only service endpoint that supports Exchange ActiveSync. From a condition standpoint, we're going to target our Exchange ActiveSync clients as a client app condition. We don't need to target any other specific conditions like device platform because we want to have this policy target all device platforms and prevent users from using ActiveSync, say, on a desktop class device, because on those devices, they should be using Outlook. Now, you may think this policy would be an outright block policy, but in fact, it's actually going to be an allow policy with the use of the require app protection policy grant access control. And the reason for this is because Exchange ActiveSync has quarantine logic built in it. This enables us to deliver tailored solutions to the users when the device and/or client doesn't meet the conditions set by the administrator. In this case, we have a basic authentication ActiveSync client, which is either not defined within the app protection policy or, which is more likely, has not integrated the Intune SDK, will ultimately be blocked by this allow policy. And because we use the require app protection policy grant access control, we deliver a tailored quarantine message back to Jane so that when she launches the mail app after successfully completing her profile setup, she will see a quarantine message that indicates that she needs to use Outlook as the app to access her messaging data on the device. If we had used any other grant access control or created a block policy, we would have delivered a different quarantine message, and that quarantine message would not have guided Jane to install Outlook. Finally, we need to think about all the other client protocols that Exchange Online supports, like POP, IMAP, Exchange Web Services, and even PowerShell. So in this policy, we're going to target our users and target Office 365 because we want to be broad and apply against all the endpoints. From a condition standpoint, we're only going to target our client apps and set that to be other clients. Now, unlike Exchange ActiveSync, all these other protocols that can be used to access messaging data do not have quarantine logic built in them. So this will actually be a block policy. And when Jane attempts to use a device like an IMAP client on a mobile device, she will be blocked. And depending on what's returned via conditional access is an access denied. And it's up to the client and/or protocol to relay that information back to the user. There's no granularity that we have available to us to provide any sort of guided flow to help Jane in this scenario understand she needs to use Outlook. Now, I will caveat this policy. This is a broad policy. It applies to all of Office 365, and it applies regardless of device platform. So everything, all legacy clients through this particular policy will be blocked. If you need granularity, you may need to look at specific conditions and/or the possibility of whether to implement this policy. For example, if you need to allow basic authentication for, say, IMAP, this policy in itself will not work for you. Conditional access doesn't give you the granularity in this case to apply the ability to block authentication on a per protocol basis. It applies to all protocols. So if you need a per protocol basis approach, you may need to scope and leverage the Exchange Online control specifically. And of course, you need to rely on Azure Active Directory sign-in reports to understand which devices, which protocols, which clients are utilizing legacy authentication. So the last thing I want to cover is advanced conditional access controls, which are available in premium SKUs of Microsoft 365. I've mentioned two of them briefly, user risk and sign-in risk. Just to reiterate, user risk is a way for Azure Active Directory through the Intelligent Security Graph, which collects billions upon billions of signals across authentication, Microsoft Defender ATP, and even Exchange Online to make a determination of the state of that user. Is that user compromised? Is that user not compromised? With user risk, we can determine if the user account is compromised. Say, for example, because Microsoft has detected that the user's credentials have been leaked onto the internet or dark web. In the event of a user risk, we can force the user to reset his or her password through self-service password reset, which requires multi-factor authentication. And then we have sign-in risk. Sign-in risk is where we evaluate the authentication risk based on the current authentication attempt, as well as prior authentication attempts, to determine if the user behavior is suspicious. For example, 2 years ago at Ignite, I was doing a live demo where sign-in risk actually took effect, and it was not something I had originally planned. I had my conditional access policies configured such that if an account was considered suspicious, i.e. had a medium risk or higher, I would force multi-factor authentication on that user. While I did the demo, when I attempted to add an account to Outlook Mobile, I was prompted to enter in my multi-factor authentication mechanism, which happened to be a text message. The reason why sign-in risk was triggered was because of suspicious travel capability. Prior to my live demo, I had rehearsed my demo in my hotel room in Orlando. That hotel room used an IP range that was based in Florida, whereas the Ignite conference used an IP range that was based in Nevada. Within the hour of me doing the test run and doing it live, that was considered an atypical travel scenario because there was no way I could physically travel between Nevada and Florida within that short period of time. And so as a result, the user was considered suspicious, and that prompted multi-factor authentication. So that's just one example of how sign-in risk can be used. You could use sign-in risk to outright block access as well, if necessary. And then finally, we have Microsoft Defender ATP, which, as I mentioned, is a mechanism by which you can use to enforce compliance validation of devices. It will do things like validate operating system vulnerabilities, detect malicious apps, and other forms of potentially dangerous mechanisms that could be used to compromise a device and assign a risk to that particular device. The compliance policies can be configured to take action on those particular risks and trigger a device to be out of compliance. And thus, when a device is moved out of compliance, access will then be blocked through conditional access. So in summary, the key things that I hope you're able to walk away from this session are the fact that you need to disable legacy authentication and you need to enforce multi-factor authentication within your environment. These two alone will help mitigate common identity-based attacks within your environment. Azure Active Directory provides you with the capabilities to enable these, either through security defaults or conditional access. Conditional access also provides you a level of customization to provide further granularity in how you protect mailbox access by enforcing, for example, enrollment and compliance on desktop devices and enforcing app protection policies on mobile apps. And of course, you could leverage advanced conditional access controls like user risk, sign-in risk, and Defender ATP to further protect access to your mailbox data. Thank you for listening, and I hope you've enjoyed this session. If you have any questions, please don't hesitate in reaching out, or you can learn more by accessing our content on Mailbox Protection with Microsoft 365. Thanks.